Hi, my name is Muhammad Hafizul Azim bin Norman, metric number 231323642. Today, I will present my opinion on selecting a suitable material for spacecraft. In aerospace engineering, material selection is very important. It does not only affect the cost of project but also safety, reliability, and long-term sustainability of spacecraft. As a metallurgical engineer, we must consider both technical performance and economic factor. In this presentation, I will compare material X and material Y using two economic evaluation methods. First, present worst analysis. Second, annual worst analysis. Both analyses are done at interest rate of 12% over a period of 5 years. At the end of this presentation, I will recommend the better material and explain the consequence of making the wrong choice. First, let's take a look at the data provided for the both material. Material X has an initial cost of RM15,000, an annual maintenance cost RM9,000, a salvage value RM2,000, a service life of 5 years. Material Y has a higher initial cost, RM35,000, a lower maintenance cost of RM7,000, and higher salvage value of RM20,000, but have the same life service, 5 years. For this data, we can see the material Y has much more expensive at the beginning, but it will offer the lower maintenance cost and higher value salvage. However, in engineering economy, we cannot judge based on the initial cost alone, but we must consider a cost over the entire life of the material, including the future cost and benefit. In spacecraft project, budgets are very limited and careful planned. Every decision must be justified because space missions are very expensive, resources are limited. Any mistake can cause large financial loss. That is why we use economic analysis method that present the worst and annual worst. This method helps us to compare alternatives fairly by considering the time value of money, which means money today is worth more than money in the future. Now I will explain the present worst analysis. Present worst analysis convert all future costs and salvage value into today value using an interest rate of 12%. For a 5-year period at 12%, we use standard economic factor to calculate. Present worst annual maintenance cost, present worst of salvage value. After performing the calculation, for material X, the present worst of maintenance cost is high due higher yearly maintenance. The salvage value is quite low for the material X. Total present worst cost for material X is RM46,311. For material Y, the maintenance cost is lower. The salvage value is much higher. However, due to the very high initial cost, the total present worst cost material Y is RM48,895. Since a lower present worst means lower total cost, material X is better based on present worst analysis. Now, let's take a look at annual worst analysis. Annual worst convert the total cost into the equivalent yearly cost. This method is useful because it shows how much the project costs per year. Using the annual worst, for 12% over 5 years, material X has annual worst RM12,825 per year. Material Y has annual worst RM13,546 per year. Again, material X has lower annual cost. This result confirming the decision made using present worst analysis. Both methods give the same conclusion, which make decision more reliable. Based on both present worst and annual worst, material X the most recommended material for spacecraft. Although material Y has a high salvage value, its very high initial cost that make less economical over 5-year life period. Material X provide better cost efficiency while still meeting the project requirement. Choosing the wrong material in spacecraft engineering can lead to serious consequences. From a cost point of view, a more expensive material can cause budget overrun. This may reduce funding for other important systems such as navigation, communication, or safety equipment. From the safety point of view, limited budget may lead to reduced testing, inspection, or quality control. This can increase the risk of system failure during the mission. In space mission, failure is not acceptable because repairs are extremely difficult or impossible. Therefore, an incorrect economic decision can indirectly affect the mission success and safety. Sustainability is also very important in aerospace engineering. Space projects use very large amount of material, energy, and financial resources. By using Material Act, the total cost of the project can be reduced. This allows aerospace limited resources can be used for more efficiency and responsibility. The saved budget can be used for improvement safety system, support system for research and development, increase mission reliability, and prepare for future space mission. This approach supports long-term sustainability in the aerospace industry. In conclusion, material selection is critical decision for spacecraft engineering. A good decision must balance cost, safety, performance, and sustainability. Based on present worst analysis and annual worst analysis, at 12% interest rate, material has lower total cost, lower yearly cost, and better use of limited resources. Therefore, Material Act is the most suitable and economical choice for the spacecraft. That's all for my presentation. Thank you.